Okay, for the homework, you should be able to do most of the questions just from looking at the notes or using your smarts, right? So go to number 6. I just want to do one of those together. So number 6, it says fill in the following information, show all work below. So they give us the wavelength and they ask you to find the frequency and then the amount of energy that would be in that wavelength of light. So I'm just going to do one. So it gives us 4.103 times 10 to the negative 7. And that's in meters. Yeah. And that is our wavelength. So that is lambda. All right. So remember our equation for this, let me get out our notes. Our equation for, our equation for frequency if given wavelength is the speed of light equals the wavelength times the frequency. Okay. We also know the speed of light to be 2.998 times 10 to the 8th meters a second. So just type that in and then solve for your unknown. So 2.99, make that a better 2. 8 times 10 to the 8th meters a second is equal to 4.103 times 10 to the negative 7th times your frequency. Divide by 4.103 times 10 to the negative 7th. Divide by 4.103 times 10 to the negative 7th. And let's see, you were going to get our frequency as, I'm kind of doing this, I'll switch it over so it makes more sense. 7.307 times 10 to the negative 7th per second. That's how many times it passes within a certain point a second. So how much energy would that be? Well, we just use our equation. So that'll be that for that first part. So we're going to use this again. So energy equals Planck's constant times our frequency. Well, we know both of those. Planck's constant is Planck's constant right there is, actually you can see it all, 6.626 times 10 to the negative 34th joules. Very small number. We times that by our frequency, 7.307 times 10 to the negative 7th second. And we get, what did I get? 4.842 times 10 to the negative 19th joules. Okay, so you should be able to answer or do the rest of the homework on your own and do those other two calculations like this. All right.